All right, so we're moving on with trigonometry, and now what we're looking at is getting into triangles that are not right triangles. And so the first thing we're going to look at to use to solve for non-right triangles is the sine law. Now, the sine law here is we have sine angle A over side A. Sine angle B divided by side B is equal to sine angle C divided by side C. And so the big letters here represent the angles, the little letters represent the sides. Now, there's two important things about this formula. Number one is what side is which. Now, over my triangle there, if I have an angle A, side A is directly across from it. And the same thing with each side. So angle B is, the side B is directly across from it, and angle C, side C, is directly across from it. So that's the first thing about this formula. You got to know where the sides actually are, where the label, correctly label your diagrams. The second thing is that there is two equal signs in this law, and there is three parts to it. Well, what we're going to do is we only use two parts of this equation, which means one equal sign. So we might use the B and the C part, we might use the A and the C part, or lastly, we might just use the A and the B part. All right, so that's the thing, is we're only going to use two sections of the sine law. All right, now starting off with an example, we do not have a right angle triangle here. That's when this is used. And again, the sine law is totally different from the sine ratio. They're like cousins. They're related, but they're different. Okay? Now, here we go. Example one. I wrote down my givens. Again, that is my first step, just about every math problem there is. Write down what information do I know, what information am I trying to find out. Okay? And so when I look at my diagram here, some of the simple stuff to write down is the angle. So it says angle B here is 54. All right, angle C here is 84. Now our side across from angle C is X, so that would be side C. So we'll put an X there. And then across from angle B, I guess that would be our 6, so that is side B right there is 6. Now, as I mentioned, in the sine law, you only need to use two parts. So how do you figure out which parts you need? The first part you're for sure going to use is the part where you don't know what you're trying to find out. So in this case, I don't know side C. So I have to use the C part. So I'm going to have sine angle C over little c. That's one part I'm going to use. The second part that you're going to use is where you know the part where you know both the side and the angle. So I look in here, in this case, well, I don't know angle A and I don't know side A. I'm definitely not using the A part. But I do know angle B and I do know side B. So I am going to use the B part combined with the C part. So there is my formula. Side angle B divided by B equals sine angle C divided by C. Now I'm going to substitute in my information and I'm going to solve. All right, so I've got sine 54 degrees, all right, which we know how to calculate because we've been doing that the last couple hours. Side B there is 6. I go over to my other side here, sine angle C. Angle C is 84, so I'm going to have a sine 84 there. And in the bottom, sine angle or side C is now called X. All right. Sine 54 and sine 84. Again, I can just type those into my calculator, assuming I'm in degree mode, and get those as decimals. So I type in sine 80 or sine 54, and I get 0.809 or 0.81, could be the same. And there's my 6 there. All right, sine 84, I type that in, and I get 0.995. And then I have an X in the bottom. All right, now, where do we go next? I have a fraction equaling a fraction. We've had that before today, that's for sure. And so to simplify that, I'm going to cross multiply. In fact, it always happens with the sine law, the fraction equaling a fraction. All right, so I am going to cross multiply. And so I'm going to have a 0.809 times x, and that's going to be equal to 6 times my 0.955. All right, so now I have my equation. I'm going to simplify the 6.995. So I still have this 0.809x. 6 times that decimal, probably going to be pretty close. Let's see, 5.967. All right, maybe I'm carrying one extra decimal place here, but extra decimals give me a better answer. And not quite done yet because I have to divide by my numerical coefficient on both sides. That's a 0 there. There we go. All right, and it looks like my x value, I take 5.967, I divide it by my 0.809, and I'm getting 7.38, and I better put some units on it, centimeters. And there we go. So very similar to how I've been doing everything today, or all the time. But we substitute write down our information, figure out which parts we're going to use out of the 3, substitute it in, and then solve. All right, so let's try a couple more of those in different settings. All right, so we get all right, so example number 2. So let's see here. So I'm going to solve for angle C here. So now we're solving for an angle. I solved for a side before. So I'm going to draw my triangle here. All right, so, and I'm going to say C is right there. Here's our A. Here's my vertex B. 10 centimeters here, 12 here. And let's see here, 40 down here. All right. So again, I'm going to follow my first step, which again is write down what information I have. Now with the sine law and a non-right triangle, I'm going to have 3 angles I got to worry about. And 3 sides. 6 pieces of information. Although again, we're not going to use them all. All right, so, well, first off, what do I want to know? Angle C. Put a question mark there. All right, what else do I know? Again, I know my angle A here is 40. All right, now sides. Across from angle A, that would be side A, so that's a 12 there. And lo and behold, across from angle C here, we have side C, which is 10. Now, again, in determining which parts we're going to use of the sine law, number one, I got to use the part where I'm actually looking for something. In this case, we're looking for angle C. So again, I got to use the C part. So I got that side angle C part divided by side C. Now we get to what other part we're going to use. Well, which other part do I know everything? Look here, well, I know nothing about B, but I know everything about A. So it looks like I'm this time going to use the A part and the C part of the sine law. Okay, so there's 2 steps down. Got my given information, figured out which parts I'm going to use. Now I'm going to substitute in and solve. All right, so I got my angle here, sine 40 degrees. Side A is 12. All right, what else we got here? We don't know angle C, so I'm going to write that down here, side angle C. But I do know side C here is 10. All right, not a whole lot of simplifying I can do here, but I can find the sine of 40. So I'll type that into my calculator and I get 0.643. All right. So here I'm at. I've simplified everything. I have a fraction equaling a fraction. So to get everything all straightened out and get rid of fractions, I'm going to cross multiply again. So I'm going to go 12 times sine C, sine angle C, I should say, same thing. Then I got 10 times 0.643. All right, well, what can I simplify? I can simplify this right here. So 10 times 6.643. Again, anytime you multiply by 10, you're just going to move the decimal one to the right. So it's going to be 6.43. All right, so there's where I'm at now. I want to solve for angle C. So I got to get rid of this 12 first. And it's attached. So the only way I can do that is to divide both sides by 12. All right, so those 12s are gone. And now I have sine angle C is equal to, let's see here, 6.43 divided by 12. That's going to be 0.5 something. And in fact, it is 0.536. All right, now we just had this on our last class. I have the ratio. I have the sine ratio. So I'm going to, but I want the angle, so I'm going to use sine inverse. So I use sine inverse, again, assuming your calculator is in degree mode. And I do sine inverse of 0.6 or 0.536, and I get my angle is 32.4 degrees. There we go. So that is how we find our angles using the sine law. All right, I got one more because I always like to, if there's a twist to a question, throw that at you. So here's a little bit of a twist coming in example number 3. All right, so let's see here. It's a word problem. We're building a bridge over a river. All right, so, well, I'm going to draw in a river here first. My lack of artistic ability. Let's see here. There's my river. I'll put some water in there. All right, there's my river. All right. And so this is example 3 on my sheet. Again, I won't be able to write down all the words, but I will read it out. So here we go. A bridge, line segment AB, is to be built across a river. First sentence. All right, so there's my A, and there's my B. A, B, building a bridge. There's a bridge right there. Okay, now point C is located 61 meters from B. I could put a C here. I can put it here because it doesn't tell me which side of the river it's on. To make a nicer triangle, I'm going to put C right here, I guess. There's C. All right, so because I have A, B, and C, I'm going to connect them here and make myself a triangle. All right, so there's my triangle. Now, the third sentence, I should say, it says angle ABC is equal to 68.5 degrees. Now, I have a triangle here, and here's kind of a twist, is what angle is that? Well, when you have angle ABC, A to B to C, essentially what it's telling you is the middle letter. Our angle B is 68.5 degrees. So I'll put that in there. All right. And an added part is it says angle ACB is equal to 42 degrees. So again, under the same method here, angle ACB, again, I'm looking at the middle letter. There's my 42 degrees right there, middle letter. All right, so what else we got here? How long will the bridge be? That's what we're asking here in the end. So again, our bridge was from A to B. So I'm going to put in a little D here. I think I missed some piece of information. What else? What did I miss here? Point C is located 61 meters from B. There we go. Okay. So now I'm going to follow the same steps. Write down my given information here. So again, with my given information, when you're dealing with a non-right triangle, we got 3 angles and 3 sides. There we go. All right, so what do I know? Well, again, my angles are the easiest here. I got an angle of 42 degrees for C. B is 68.5. A, I don't know. Okay, on to the sides. Across from angle A, there's 61, so that is my side A. D here, which that's a side we're looking for. It's across from angle C, so D is actually C is actually D. Okay, the distance. Why it's called D. Now, which parts are we using here? So I'm looking. I need side C because that's actually our distance. So I have to use the C part. That's going to happen. That's happened every time here so far, but now I get to the other part. Which other part do I know everything? I look at the A part, I'm missing the angle A. I look at the B part, I'm missing side B. Stuck. Is there a way I can find one of those out? Anybody?
Triangle always equals 180 degrees altogether, so just add the amount of angle B and angle C, and then subtract that from 180.
That's right. All right, so angle A, as you said, I'm going to do exactly that. I'm going to add these two guys up here, 68.5 plus 42. We do subtract them, as you greatly said, because all the angles inside of a triangle add up to 180. And let's see here. I actually get that angle A is 69.5 degrees. All right, so now I know everything about the A part. So I'm going to use the A and the C part. All right, but just as I did before, I type in my information and solve for C this time, which I'm going to end up calling D, our distance. So here we go. So I'm going to substitute in. So I got sine of 69.5. All right, my side A is 61. All right, side angle C, that's going to be, angle C is 42. And side C now is called D because it's called the distance. All right, again, I have sine 69.5 and sine 42. I can type those into my calculator and get, let's see here. Sine 69.5, I'm getting 0.937. Of course, divide that by 61. Sine 42, type that in, I'm getting 0.669. And I got the D in the bottom. All right, so now there's where I'm at. So, of course, I'm going to cross multiply, right? Because I have a fraction equaling a fraction. That'll help me out here. So, let's see here. I get 0.937 times D. 0.937 times D is equal to, boy, I'm running out of room here. Let's see, 61 times 0.669. So I'm just going to figure that out. 61 times 0.669, I get 40.81. All right, and then lastly, to get D by itself, find the distance of this bridge, or the length of it, I should say. I'm going to divide both sides by my numerical coefficient, which is the 0.937. All right, and so my D value, I got 40.1 or 40.81 divided by the 0.937. That's going to be like 40 something. Let me see here. 43.55, and we're talking about meters here, would be the length of your bridge. So there's our sine law where we looked at solving a side, solving an angle. And then, of course, our third example here, where I was, as I move along, I like to show you some of the twists of the tricks, where, again, how to figure out what these type of angles mean when it's labeled like that. And then bringing in that grade 9 fact, maybe use it in grade 10 a little bit, where all the angles inside of a triangle add up to 180. So you might see that too. All right, so